Example, this one's a rough one, but this is the absolute hardest you'd wind up coming across in class and a test, so don't worry. This is basically a top difficulty you'll have to deal with. Probably. You might see something a little bit harder, but this is really about as hard as it's going to get. All right, so happily, they already factored it for us, and we've got t minus 2 squared, t squared plus 2, so this is degree 2, this is also degree 2, so that combines to degree 4 on the bottom, degree 3 on the top, so we're proper. Our bottom's already factored. We just need to actually work through the decomposition now. So we've got negative t cubed plus 8t squared minus 6t over t minus 2 squared, t squared plus 2. So how does that decompose? A over linear factor of t minus 2 plus b over our second version of that linear factor, so t minus 2 squared, plus cx plus d over our irreducible quadratic factor of t squared plus 2. Great. So at this point, we multiply both sides by the denominator. Multiply both sides by the denominator, and we will get negative t cubed plus 8t squared minus 6t equals a times, so it got hit with t minus 2 squared times t squared plus 2. So it's going to cancel out one of those t minus 2's, and it will be left being multiplied by t minus 2 and t squared plus 2. Plus b, t minus 2 squared was in its denominator, so it's going to cancel out all of the t minus 2 squared that hit it, but not the t squared plus 2 at all. So we've got t squared plus 2. And then finally, plus cx plus d, and it's going to have to go in parentheses because it got hit by another entire thing, and it's going to get t minus 2 squared, but it did cancel out the t squared plus 2 that hit it because it had that in its denominator. So at this point, we want to start simplifying things out. So we've got a times, what is t minus 2 times t squared plus 2? So we get t cubed, t plus 2t, sorry, t times 2 becomes 2t minus 2t squared minus 4, okay, plus bt squared plus 2b, okay, plus cx plus d times t minus 2 squared becomes t squared minus 4t plus 4. All right. Move a little bit to the left so we have more room. Still the same thing on the left side. So we've got at cubed plus, sorry, minus 2a t squared plus 2at minus 4a, whoops, try to switch colors there, plus bt squared plus 2b, break onto a new line now so we can see what's going on. Cx times t squared will become c, whoops, made a mistake right from the beginning. It should not be x. It should be, I just stuck with what I've been used to, where a variable that we're dealing with isn't x, it's t here. So that should have been a t the whole time. Sorry about that. But that's the sort of mistake you want to catch on your end too. Because we're dealing with a variable, we're dealing with t as our variable. So while the form was with x as before, that's because the variable was x before, but now we're dealing with t as a variable, so the form needs to switch to using t. So let's work this out. Ct times t squared becomes ct cubed. Ct minus 4t becomes minus 4ct squared. Ct plus 4ct plus dt squared minus 4dt plus 4d. Whew! Okay, got a lot of stuff here. So we can say this is negative t cubed plus 8t squared minus 6t equals, and we can put this in that form again of thing of exponent 3, exponent 2, exponent 1, exponent constant, minus 2at squared plus 2at minus 4a. Next one, plus bt squared plus 2b plus ct cubed minus 4ct squared plus 4ct, and then plus dt squared minus 4d t plus 4d. So from this, we'll be able to figure out that all of our t cubes, right, our line of t cubes here has to be the same as our line of t cubes here. So we'll be able to get things like -1 equals a plus c. Now, this is a lot of stuff to have to work through, right? We've got 4 different variables. We're going to wind up having 4 different simultaneous linear equations that we're going to have to solve through. If you've done much work with simultaneous linear equations, you know that's going to be kind of a pain to work through. So at this point, we might think, I'm lazy. Is there anything clever I can do? Is there a clever way to work through this? Some little trick I could use? Well, if we look back to what we originally had when we multiplied out that denominator, we might go, well, oh, hey, look. There's a t minus 2 here, there's a t minus 2 here, but there is an absence of t minus 2 on our b. So if we realize that, we could go, well, if we plug in t equals 2, right, that would cause, now, none of this stuff up here is not going to be true, but we're going to plug in t equals 2, and we're going to realize if we plug in t equals 2, that causes this to turn to 0, which knocks out our a terms. And it will cause this here to turn to 0 as well, and it will also knock out our c and our d terms, and we'll be left with just b times t squared plus 2, where t is 2, only t is 2, and negative t cubed plus 8t squared minus 6t when t is 2. Now, this is true for any t, right? So that means we can plug in any t we want, and if there's a convenient way to get certain things to disappear by plugging in a cleverly chosen t, it's fair game, right? Anything we can do to help us work through this, anything that makes it easier, it's fair game. So in this case, we notice that by plugging in this carefully chosen t, we can get certain things to disappear. Now, it's true for any t. This equation, this whole thing here is true in general for any t before we crossed stuff out. But in the specific case where we plug in t equals 2, certain things will cancel out, and we'll be able to figure things out in a very easy way mathematically. So we plug this in, and we know that on our left side, we're going to have negative 2 cubed plus 8 2 squared minus 6 times 2 equals, sorry, not quite a lot of room here. I'm going to draw in a line just so we don't get confused, equals b times 2 squared plus 2. Okay, so we've got negative 2 cubed is 8, plus 8 times 2 squared is 4, so 32 minus 6 times 2 is 12, minus 12 equals b times 4 plus 2, or 6. Simplify the left side, so negative 8 minus 12, negative 20, 32 minus 20 gets us 12 equals 6b. We divide both sides by 6, and we get 2 equals b. So, by use of some cleverness, we were able to skip having to do 4 simultaneous linear equations to eventually we're effectively going to bring it down to 3. And we'll be able to not have to get confused by this most complicated column where we've got 4 different things all going together. We can just be done with b. B's already figured out, which will be really helpful and make things easier on us down the road. We could have solved out those 4 simultaneous linear equations because each one will produce things. Remember how the first column produced -1 equals a plus c. Each one of these columns will produce a equation, and from 4 simultaneous linear equations, solving for 4 variables, we'll be able to do it. It's just kind of a pain. So we came up with this clever way, and we were able to figure out 2 equals b by just happenstance. If we plug in t equals 2, it made everything but the b terms disappear, and that just left us with a single equation that was pretty easy to solve, and we figured out that 2 equals b. All right, let's work through it now. So we figured out b equals 2. And now we've got negative 2 cubed plus 8t squared minus 6t equals at cubed plus ct cubed minus 2at squared plus bt squared minus 4ct squared plus dt squared plus 2at plus 4ct minus 4dt minus 4a plus 2b plus 4d. Hoi. Okay, so at this point, let's put columns to columns. So negative t cubed goes to our at cubed plus ct cubed. So it must be that -1 is equal to a plus c. So -1 equals a plus c. We can do this column here. I accidentally cut through that negative sign. Hopefully that wasn't too confusing. So that one here lines up with the -6t. So we've got that -6. Let's write it on a separate location. -6 equals 2a plus 4c minus 4d, right? They've all got t's showing up, so we just divide out the t's and we're left with this simple, linear equation we can work with. And then finally, the last one of constants. Well, what's our constant? Our constant is 0. So we've got 0 equals negative 4a plus 2b plus 4d. For extra credit, let's just see what this would have been. How many t squareds do we have? We had 8. So in our difficult to read yellow, I'll make it black just because black's easier to read. 8 equals negative 2a plus b minus 4c plus d. We could have worked that one out, but I want you to see what it would have been, but we'll actually wind up having enough information because we've got 3 equations, 3 unknowns, so we've got enough with the red, blue, and green things. So at this point, let's figure out a first. So that means we need to solve for everybody who isn't a so that we can plug them in, get rid of everybody else, and just have a. So on the left side, we've got negative 1 equals a plus c. So we solve for c, and we get negative a minus 1 equals c. Okay. On the green one, we plug in what we know for our b. We've got 0 equals negative 4a plus 2 times 2 plus 4d. 0 equals negative 4a plus 4 plus 4d. 0 equals, let's divide everything by 4 just to make things easier, negative a plus 1 plus d. So we move that stuff over, and we get add a on both sides, subtract by 1 on both sides, a minus 1 equals d. So we've got a minus 1 equals d. We've got negative a minus 1 equals c, so we can plug this information in to this equation, and we'll be able to get something that is just using a. Negative 6 equals 2 times a. That guy actually sticks around because he was just a from the beginning. 4, what did we figure out c was? C is the same thing as negative a minus 1. Negative a minus 1 minus 4 times, what do we figure out d is? Same thing as a minus 1. Simplify that out. Negative 6 equals 2a plus 4 times negative a, so we'll make that minus 4a minus 4, negative 4a minus 4a, and negative 4 times negative 1 becomes plus 4. So at this point, we see we've got negative 4 and plus 4, so those cancel each other out. We've got negative 6 equals 2a minus 8a, negative 6 equals negative 6a, and thus 1, divide both sides by negative 6, equals a. With 1 equals a in place, we can now easily go back and figure out everything else. So we've got negative a minus 1, so negative, plug in our knowing that it's 1, minus 1 equals c. So we've got negative 2 equals c. Great. And also plug in over here, and we've got that 1 minus 1 equals d. Turns out d is just 0. So at this point, we've figured out all the things we need. So we had this set up as t minus 2 and plus t minus 2 squared plus t squared plus 2, right? It was in the format negative, it was in the format negative t cubed plus 8t squared minus 6t all over t minus 2 squared times t squared minus plus 2. Okay, so that's the case. We had that as something over t minus 2. It was a over t minus 2 plus b over t minus 2 squared plus cx plus d, right? Cx plus d over t squared plus 2. Okay, so at this point, we can actually plug in our numbers. So we've got a is 1, so we've got 1t minus 2. B is 2, so we've got 2t minus 2 squared, plus c was negative 2, so minus 2x, and 0 was d, so that part just disappears. So we've got negative 2x over t squared plus 2. Whoops. Once again, did it again. got thinking in terms of x as opposed to the t, but we're using a different variable, negative 2t over t squared plus 2. And there we are. We've decomposed it into its partial fractions. That is pretty long, it's pretty complicated, but that's pretty much as hard as it gets. As long as you break it down and then you multiply everything out carefully and you're careful with all of your algebra and your arithmetic, you can get it into this form right here where you've got this big block compared to these original things, and then you're able to figure out all these linear equations, and you can possibly be clever and have her figure out some way to get, b equals 2, but you also can just work through a bunch of linear equations, solving for one thing at a time in terms of the other, plugging them all together, and then solving it out. Sometimes it takes a lot of work, sometimes it goes kind of slowly, but ultimately if you just keep plugging away at it, you can get it. And it's really, really useful in calculus. I know you aren't going to be using it immediately, but honestly, this thing makes a problem that would be otherwise totally impossible to do just a piece of cake. So it's a really handy thing in calculus. All right, we'll see you at Educator.com later. Bye.